When solving a dosage problem where we're given the patient's weight in pounds, our first step is always to convert the pounds to kilograms. We'll do that using one of two conversion factors. What we need to know first is that there are 2.2 pounds in every kilogram, and every kilogram contains 2.2 pounds. That's the relationship between kilograms and pounds. So we'll take our weight, 112 pounds, and remember LBS is our abbreviation for pounds. We're going to multiply that by one of our conversion factors. We want pounds to be able to cancel, and we want kilograms to be on top, therefore ending up in our answer. So we're going to use this second conversion factor. We'll write 1 kilogram over 2.2 pounds. And what's going to happen here is we're going to multiply across the top 112 times 1, which is just 112, and then we're going to divide by what's on the bottom. So we've got 2.2 pounds down here, so it'll be 112 times 1 divided by 2.2. And if you remember from algebra, when you have something on the top and something on the bottom, and they're the same unit, those cancel, and you're left with the unit remaining on top, which is kilograms, and that's what we want. So 112 times 1 divided by 2.2 gives us 50.91 kilograms. Now we'll look in the problem and see where there are kilograms, and we'll see that in our dose, 0.8 milligrams per kilogram per day. We can write this as 0.8 milligrams need to be taken for every kilogram of body weight. And we'll multiply our kilograms of body weight times this conversion factor. So 0.8 milligrams on top, 1 kilogram on the bottom. And what we see here is, again, kilograms over here cancel with these kilograms on the bottom, and that's going to leave us with milligrams of medicine needed per day. 50.91 times 0.8 on the top divided by 1 on the bottom. That gives us 40.728 milligrams. Now we know how many milligrams this patient needs to take per day, which is great. But the problem asks for one more thing. It wants to know how many actual tablets, because we may know how much medication the patient needs to take, but that does not mean that we know how much is going to be needed in the form that the medication comes in. So this medication comes in tablets. So 1 tablet contains 20 milligrams. We could also write this and say that there's 20 milligrams per every tablet. But we're going to use this first conversion factor because it's going to allow us to cancel these milligrams on the bottom. So we'll write that over here. Oops. And we'll say that 1 tablet and let's see. So we're going to use this first conversion factor, and we'll say that 1 tablet contains 20 milligrams of medication. Our milligrams are going to cancel because we've got them on the top and on the bottom. We'll take 40.728, multiply times 1, and divide by 20, and that gives us 2.036 tablets, which we can round to 2 tablets, so we're not giving our patient a fraction of a tablet, and that would be our final answer.